So we use that formula above to prove it, but our actual result is here. The derivative of a to the x is a to the x times ln a. Now, this is just when we need to use the chain rule. So a quick example of this one would be if you just have 2 to the x. So if you just have,
Why is this camera?
Are they going to come inside?
I guess they're just walking around. Okay. So this one, when it's just 2 to the x, it's 2 to the x times ln 2. That's just plugging into that formula. However, what if we have let's do to the sine x. Oops. So the first time, just like with the e to the x, we have 2 to the sine x times, oops, what happens when we take the derivative? Times cosine. And that's it. There's not really anything we can do to simplify that.
We don't have the ln a anymore?
Oh, did I forget? Sorry.
Oh.
I did forget that. ln of 2. There. Okay, now we have it. So when you have the chain rule, it's basically, it's like 3 things. It's 2 to that power times ln of the base, which I forgot originally, so that should have that ln of 2, times the derivative of the exponent, so the chain rule.
So because we're not needing that, can you give us some
Lauren, listen.
You won't encounter, so the second formula, you won't have too much of this. Most of the derivatives that I will ask of you will be the e to the x form.
Can you put all the ones that you want us to know on the practice test? Like you wouldn't give us anything else on the practice test, you wouldn't give us on the
Well, then
What you wouldn't give us on the
I can't promise you that, but I will make sure. So I already had the practice test to give to you guys today. What I will do is make sure if there's something missing on there that I'll make sure that you need to know. Like for example, I may have a sine and a tangent, but maybe I didn't ask you cosine, but I want you to know the derivative of cosine.
Okay, yeah, but that's
All right?
it.
Yeah. And we'll talk about that, yeah. All right, example 2. At what point on the graph of the function y equals 2 to the t minus 3 does the tangent line have a slope of 21? Okay, so I need to find, oops, not D.
Oh.
Yes,
I'm just telling you that I'm thinking really.
okay. There's a practice test in that calculator drawer.
Why is it dy
Okay, so the reason I'm putting dy dt instead of dx, the reason I erased it is because the other variable involved is a t, not an x. So it all depends on what the variable is used within that problem. Okay, so the first thing is going to be 2 to the t times ln of 2. Do we need to use the chain rule? No, because it's just t. I mean, if you wanted to, you could. It would just be multiplied to 1 times 1. And then derivative of minus 3 would just be 0. Now, I want to find out when we have a slope of 21. So I'm going to set this equal to 21. Okay, so now it turns into basically an algebra 2 problem. How do I solve when there is a variable in the exponent? So I'm going to have to take natural log of both sides, but first thing I want to do, I'm going to divide by ln 2. Let me draw it over here. So we have 21 over ln 2 equals 2 to the t. The only way we can get rid of the variable in the exponent, or to be able to move the variable outside of the exponent is to take either the log of both sides or the natural log of both sides. Does it matter which one? Are you guys okay with that?
Yeah.
So I'll just write ln. That allows us to use the power property and move it to the front. So I have ln of this whole thing equals t times ln2. Right, and then we're going to divide by ln2. Somebody go ahead. Be careful. 4.921.
How do you do that many LN?
Well, you can do it in steps. I mean, you could just do 21 divided by ln2, and then take ln of that answer, and then divide by ln2. Sam, can you tell me one more time, what did you get?
I got 4.921. I mean, someone should check that.
4.921.
Yeah, it is.
Casio backs it up.
Your calculator's like written there.
What? No?